Hi all. So I heard a small suggestion from my friend that it would be really good, or I would get more views if I post my content in English. So that's why there's a switch in English. So it's just what I'm going to do now is a small recap of what I said in the last video. So a signal means simply you can just take your pen and scribble like this in the time axis, then that's a signal. A y is equal to sine t, that is a signal. Whereas if you take a parabola like this, which is y square is equal to 4 it is not a signal but it is a function, and the reason for that is at given one particular point of t there is two values for this function, so it can be a function but never a signal. So that is what we are trying to tell here by the difference between signal and a function. Next I was talking about how we sample a function to make an analog signal into digital signal, but before making it into a digital signal there is another classification of signals. It's basically not a classification, it is generally based analog signals and discrete signals. Discrete signals turn into digital signals. So as of now, let's not talk about digital signals, we'll just name it as discrete signals. So you take your pen in your Cartesian axis, you just or in any axis, you just scribble it like this. Let this be time and let this be some y of t. So this is your signal. T is equal to 1, t is equal to 2, t is equal to 3. So a different instant here t is equal to 4, t is equal to 5. So at different instance of time you just see what is the value at y is equal to t axis. So basically what you did is you are just seeing or you are just measuring what is the value of the signal at different instance of time. So this is called sampling. Okay, this is somewhere close here. So as I told, so this is called sampling. When you do it in a very frequent way, that is instead of 1 second, if you just put it like here, now here you are sampling for every 1 second, right? T is equal to 1 second, t is equal to 2 second, t is equal to 3 second, like that. If you sample it for every 0.1 second, you will be able to get the dots like this very close only. So you will be almost able to recreate the signal only. So this is called sampling. So as I told, why we sample, in nature it is available only as analog signals, and our machines to process the received signal in analog format, it's going to have really big trouble. So we convert it into digital signals. So the very first step of conversion into digital signal is sampling it. When you sample it, you will get some. So if you look at the discrete plot of it, it would look something like this. So only dots, you will not have, it will not be continuous, it will be dots because you are measuring only at that point of time. So it will only be dots. So that is what I was telling about sampling in the last video. And what do you mean by quantization? If you put different levels in the y-axis, and if you segregate whatever is lying between this and this is in this line, whatever is lying between this and this will be this value, whatever is lying between this and this will be this value. So if you segregate it like this, then it's going to be digital signals. Actually after sampling, if you segregate the values according to the different amplitudes in the y-axis, it's going to be a digital signal. So that basically sums up how an analog signal is converted into a digital signal. First it will be discretized, then it will be segregated according to different values in the voltage or in the amplitude. Voltage is basically when you have an electrical voltage signal, it's voltage, so I meant it like that. So when you segregate it according to the value of amplitude, so when you quantize it, you basically convert an analog signal into a digital signal. Next, moving on, one main classification or one important thing in this signals and systems is periodic signals and non-periodic signals. So when I tell periodic signals, it will be from the name it will be very obvious for you. The signal which repeats after every particular instant of time, that's periodic signal. For example, it is sine wave. Sine wave, you see, basically this part repeats after this, again it will repeat, so sine wave is a periodic signal. So if you take this to be 1 second and this to be, what will this will be 2 seconds, that is 1 second. After 1 second it got repeated again, so 2 seconds. Here it will be 3 seconds, so it is getting repeated. So this one element, this one signal is getting repeated again and again in a periodic way, so it's called periodic signal. So this is periodic signal. If you would ask me what is non-periodic signal, if it does not repeat, then that is non-periodic signal, as simple as that. So any signal which does not repeat, that can be drawn easily. Just take a pen, scribble it like this is a non-periodic signal. Okay, so this particular thing is repeating after 1 second. So is it necessary that it should repeat after 1 second? No, it can repeat after 0.1 second. Like this duration, instead of 1 second, it can be 0.1 second, and this entire thing can repeat after every 0.1 second. The thing is, this difference, that is this 1 second, should be maintained. Here the difference between any any entity, like any starting point and ending point, should be 1 second. That is the key idea. So how frequent it repeats itself tells us what is the frequency of the signal. If so, how do we define the frequency of a signal is how frequently a periodic signal repeats itself. That's called the frequency of a signal. So if we take this 1 second, so it repeats after every 1 second. So after every 1 second it repeats, so it's 1 hertz. So if we take this 0.1 second, so after every 0.1 second it repeats, so 10 hertz. It's like that. So so whatever we see, whatever radio signal and all, whatever FM radio that we are getting, they're all in megahertz. And whatever we are using in 5G, that are all 5 gigahertz bandwidth. So that is the range of frequency that we are seeing in day-to-day life. So like that, this way whatever I've drawn here is 1 hertz, 10 hertz, like that. You might think, why am I running like this? Because whatever I'm telling now is the very basics, whatever that they would have taught you in college. Just to, these things I need not specifically put a video so that you guys can understand. Just that, like a recap for whatever you learned in college. Maybe after some videos progress, the concept that I'm going to tell, maybe that will help you in your understanding of the concept, rather than whatever that is being rather than the understanding that you gained in your college. So now let's suppose there is a signal, again a random signal like this. Now this signal, so at t is equal to 2, the value, it's here. At t is equal to 8, it's here. So similarly 3, 4, 5, 6, 7 and all, it's here. Okay, and 8 is here. So that's how this signal is there. Now let's suppose this is some x of t. Now someone is telling me what will be x of t plus 4. Okay, so if x of t is this, what will be x of t plus 4? So that is again very simple. Now suppose at t is equal to 2 second. Okay, now let's suppose t is equal to 2 second. You will put 2 here. So if you put 2 here, it will be x of 2 plus 4, which is x of 6. What is x of 6? 3, 4, 5, 6. So 6 is somewhere here. So at 2 I have to put the value that I am getting at 6. So let's suppose that this is some 1, 2, 3, 4, 5, 6. So at 2 I should put the value that I am getting in 6. So at 6 it's somewhere here. Okay, so I'm putting it here. And again, suppose I'm putting x of 3 plus 4, which is x of 7. So at t is equal to 3, so these are all my actual t values. At t is equal to 3, I have to put something which is here at x is equal to 7, because x is equal to 7. So if I put x is equal to 7, it's roughly somewhere here. Similarly, if I put x is equal to 4 plus 4, 4 is my actual t, but what am I supposed to put this time? X is equal to x of 8. So x of 8, it's 0 here. So at x is equal to 4, I am supposed to put whatever is there in x is equal to 8 here. So like that I have to put, let's suppose I'm putting x of minus 4 plus 4, which is equal to x of 0. So at x of minus 4, let's suppose minus 4 is somewhere here, I have to put something at whatever is there in x of 0. What is there in x of 0? It is 0 only, so I can keep it as 0 only. If suppose it is x of minus 2 plus 4, it should be x of 2. So at x is equal to minus 2, I am supposed to put something that is here at t is equal to 2. Like, so I mean when the t is equal to minus 4 or minus 2, I am supposed to put whatever is there in x of 0, x of 2, those values I am supposed to plot. So that is, this 2 should be coming here. So I hope you are able to understand whatever I am trying to tell. Suppose if it has to be 0 here, I want x of 0 here. That is, I need to know what is the value here in this axis. Okay, so what will we do? We have x of some value I have to put, plus 4 is here, which would ultimately end in this thing, that is x of minus 4. So t will be minus 4. So I have to check what is the value in minus, if I put minus 4 and plus 4 here, so it would actually end up in x of 0. So I am actually supposed to put whatever is x of 0 here. So that's how we are supposed to check. Now suppose you want x of 4 here. Okay, so basically what you need is, you need to know where t is equal to 2, t is equal to 3, you want to know where will this value lie exactly in t plus 4 graph. So what you do, you will put x of 4 here. If you need 4 here, it should be 0 plus 4. So at 0, so what we find is, at 0 here, at t is equal to, at 0 in this axis, we should be putting a value which was actually there at t is equal to 4 here. So at whatever was there in t is equal to 4 here will be coming here at 0. So at here, so it will be like this, and whatever was there at t is equal to 5 automatically will be coming at t is equal. So you will be able to roughly plot this, whatever was here like this. So it actually varied from 2 to 8. Now it basically moved to minus 2 to 4. If you see the difference, that is going to remain the same, 6. But what happened basically is, we just shifted this 2 by 4 towards left. So you see what happens, it shifted left. So that is like a thumb rule. If suppose there is x of t and you are adding some t naught here, in how we added 4 here, if you are adding some t naught, you will basically, if there is this plus sign, you will be shifting it towards your left. And obviously by analogy, if at all x of t minus t naught, if there is a minus instead of plus, what will happen? And you will be shifting it left by t naught. If it is minus here, you will be obviously by analogy shifting it right by t naught. So that is the basic idea here. So if it is plus, you have to shift it left. If it is minus, you have to shift it right. So this thing entirely is known as time shifting. This is an operation that is performed in Signal, like how we have addition and multiplication in numbers. We have this time shifting in Signals. So like this, time scaling, time reversal, everything is there. If I tell everything in this video itself, it will be too much content for you in one video. So I'll have the rest for the next video. Thank you.